Hello there, Mrs. Lohoff here. This is lesson 3.2 edition of fractions. We're going to work on three things in this lesson. The first two are going to help you to add fractions that have different denominators. Denominators are the numbers at the bottom. So the two skills I'm going to teach you, one is called greatest common factor, and the second one is called factorization. So first we're going to go over those two, and then we'll go over how to use them to help you add fractions where that bottom number or denominator is different. All right, the first thing I do, and let me move this out of the way. Here we go. In order to determine the greatest common factor, I want to look at these words and talk about the words themselves. We have the word factor. Factor is a number we multiply to another number to come up with a product. So a factor simply means a number to be multiplied. Common means what do they have that's the same. And greatest means biggest. So we need to look at the numbers 3 and 30 and determine what factors they have that are common or the same, and then which one of those numbers is the biggest. That's what greatest common factor means. I teach it in a different way than the lesson pages will do it, and I've been teaching it this way for years, and it makes a lot of sense. So the first thing I do is I make a T underneath the number. Normally I have the number in the middle, but I'm kind of running out of room with my camera right there, so bear with me, please. And then I start to count. I start counting with the number 1. Every single number has a factor of 1 because we can multiply 1 times that number to get the number. So I start by writing my number 1 and I think, all right, what number do I multiply by 1 to get the answer 3? 1 times what equals 3? Well, 1 times 3 equals 3. And I write 3 on the other side. So I have 1 on the left times 3 on the right. Those are the factors, one set of factors for 3. All right, so I've counted 1. The next number in counting is 2. And I think, all right, 2. Can I multiply 2 by a number to get 3? I can't. All right, let's go to the next number, 3. I already have 3 on the other side, and as soon as I've repeated a number, I'm done. So the factors of 3 are 1 and 3. That's it. Let's use the same process to determine the factors of 30. Same thing, we count. So start with 1. What number multiplied by 1 gives you 30? 1 times what is 30? 1 times 30 is 30. So I'm going to write 30 on the other side. That is our factor pair multiplied together to get 30. All right, 1 is done. Next number when we're counting is 2. Can I multiply 2 times a number to get 30? Yeah, 2 times 15 is 30. Okay, cool. Let's keep going. 3. Can I multiply 3 times a number to get 30? I can, so I'm going to write 3. And if I multiply 3 times 10, I get 30. All right, wow, 1, 2, and 3. Let's keep counting. 4. Can I multiply 4 by a number to get 30? I can look at my multiplication chart and find the 4 and either follow the numbers down or find it on the side and follow the numbers across and look, and it's going to say 4, 8, 12, 16, 16, and then 20, 24, 28, 32. It skipped right over 30. I can't multiply 4 by a number to get 30, so I'm not writing it down. It's not a factor. All right, so we finished 4. Let's talk about 5. Yeah, 5 times 6 is 30. So I write 5 and 6. All right, we're done with 5. The next number when we're counting is 6. And we have 6 over here on the other side. That means we're done. So the factors of 30 are 1, 2, 3, 5, and then I read up the other side, 6, 10, 15, and 30. So we have our factors done. Now, what do they have which factors do they have in common? Which factors are the same? Well, both of them have 1, I see a 1 over here, and I see a 1 over here. They will always have 1 in common. I also see 3 on both lists. I see a 3 over here and a 3 over here. We don't have any more common factors because those are the only factors for 3. So we've found all the common ones. Now, which one of those numbers is the greatest or the biggest? And that would be 3. 3 is bigger than 1. So the greatest common factor between 3 and 30 is 3. Let's do another greatest common factor. And if you wanted to skip forward and move to something else, you can do that. I'm going to move myself here so that I can get my T-chart to line up better. All right, let's factor 4 and 60. Start with 4. We start by counting. 1 times 4 is 4. All right, next number is 2. 2 times 2 is 4. All right, 3. I can't multiply. It's not 3 and 1, that's adding. I can't multiply 3 by anything to get 4. Move on to 4. We already have 4 here. We're done. We've got all the factors of 4. It's 1, 2, and 4. Now let's do 60. It's a bigger number, but we can do it still by counting. 1 times 60. Can we multiply 2 times a number? Yeah, 2 times 30. Can we multiply 3 times a number? Yeah, 3 times 20. All right, can we multiply 4 times a number? I might have to look at a multiplication chart for that. We can. 4 times 15. Wow, lots of factors in this one. How about 5? Yeah, I already wrote it down because I know it can be multiply 5 because it ends in a 0, and I know that rule. So 5 times, 12. And I know 6 and 10. Notice what's happening here. My numbers on the left side are getting bigger, and my numbers on the right side are getting smaller, and the gap between them is getting less and less. All right, so we have all of these factors. Now we've counted to 6. Let's think about 7. Can I multiply 7 by a number to get 60? Nope. How about 8? Nope. How about 9? Nope. That brings us to 10, and we already have 10. So the factors of 60 are 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, 60. This way of determining the greatest common factor, or just the factors in general, gives us all the factors in order from least to greatest. It's a great way to do it. It's not the way the lesson teaches it. All right, we have factors done. Let's see which ones they have in common. Well, 4 only has 3 factors. Of course, they're both going to have 1. And they both have 2. And they both have 4. Those are the common factors. Out of those, which one is the greatest or the biggest number? That would be 4. So the greatest common factor between 4 and 60 is 4. This is greatest common factor. Let me show you the other skill. That's called prime factorization, and it's a little bit different. For prime factorization, I'm going to look at this number 8, and I'm going to say, hey, what numbers can I multiply together to get 8? And I don't want to use 1 and 8. I need to use other numbers. I can look at my multiplication chart if I need to, or maybe I know that 4 times 2 equals 8. Now for multiplying, 2 cannot be broken down anymore other than multiplying it by 1. But that's called a prime number. If I can only break down a number by multiplying it by 1, that number is prime. Numbers like 2, 3, 5, and 7 are all considered prime numbers because I don't have any fact to multiply them, no factors to multiply together except the number and 1. 4 I can break that down. 4 is the same as 2 times 2. Now I'm left with all 2's, which are considered prime numbers. And that tells me that 8 is the same as 2 times 2 times 2. I take each of these prime numbers that I have. There are 3 of them, and that becomes my prime factorization. Let's try another one. 32. All right, well, 32 is 8 times 4. And we know that 8 is 4 times 2. I can't break that 2 down anymore, but I can break the 4 down into 2 times 2. And this 4 can get broken down into 2 times 2. This is the tricky part of prime factorization. You need to find the bottom of every tree and find that prime number. So here's one, here's one, here's one, here's one, and here's one. That means that 32 is the same as 2 times 2 times 2 times 2 times 2. If we want to check that, we know that our order of operations says we multiply from left to right in the order that we see them. Let's do that. 2 times 2 is 4. And then if I copy the rest of the 2's in here, we'll keep going. 4 times 2 is 8. Multiply this one, 16. And 16 times 2 is 32. So it works. All right, let's now use these for looking at equivalent fractions. We need to create an equivalent fraction before we can add them when they have different numbers at the bottom. Equivalent, do you hear the word equal in there? It just means equal. Equivalent means equal fraction. So if I have the fraction 8/44 and I want to change it so the denominator is 11, I need to think about what I can do to get from 44 to 11. Or can I multiply? I notice that the number is getting smaller, so that means I'm dividing. But if I think of it the opposite way, do I know a number I can multiply 11 by to get to 44? 11 times 4 is 44, so that means 44 divided by 4 equals 11. If I do that to the bottom or denominator of a fraction, I have to do it the same exact thing to the top. I divided by 4 on the bottom. I'm going to divide by 4 on the top. 8 divided by 4 is 2. So the equivalent fraction for 8/44 is 2/11. This is also called writing it in simple terms. It's the same thing. All right, let's try another example. 63, we don't know what the numerator is, and we want to change the numerator to 21. So our fraction would be 5/21. That's not easy to say. 5/21, I think. And how would we write an equivalent or equal fraction to that? Well, my number 63 to 21 is getting smaller. And again, I'm going to think about dividing. Can I divide 63 by something to get 21? Yeah, I can divide it by 3. So if I do that to the bottom, I have to do that to the top. Now, we don't know this number. This is one of those facts that's kind of backwards. A number divided by 3 equals 5. That's a turnaround fact for division. 5 times 3 is going to equal that same number. That number is 15. So 5/21 is equivalent to 15/63. That's how you write an equivalent fraction. Now, if you are asked, hey, find 3 equivalent fractions, create them, you get to do whatever you want to the fraction to create an equivalent one. So they're giving us 21/24. Let me make an equivalent fraction. I can multiply or I can divide. It's completely up to me. I can multiply by 2. If I decide I want to multiply by 2, I have to multiply both the top and the bottom by 2. 21 times 2 is 42. 24 times 2 is 48. So there is one equivalent fraction. All right. I'm going to make it easy on myself. What if I multiply it by 10? Let's multiply both the top and the bottom by 10. Well, 21 times 10 is 210. And 24 times 10 is 240. To create equivalent fractions, all you have to do is do the same thing to the top and the bottom, and it will create an equivalent fraction. I noticed something about this number. I know that both 21 and 24 are divisible by 3. I can divide by 3. I could also multiply by 100 if I wanted to, and that would be a third equivalent fraction, but I'm going to divide by 3. 21 divided by 3 is 7. 24 divided by 3 is 8. So my third equivalent fraction is 7/8. That was a lot in this lesson. So break it apart, come back and watch it again. Make sure you come to the live classes. We've talked about greatest common factor. We talked about prime factorization. And we talked about creating equivalent or equal fractions. All right, remember, if you need extra help, please just reach out, and I am here to help you in any way I can. Those 1 o'clock sessions are excellent ways for you to get the help that you need. All right, bye.